Welcome to Get Your FRQ On. This question is from 2015. It's question 5, and it is not calculator active. In the question stem, we are told about a function f which is twice differentiable. We are given a graph of the derivative of f, and we are given some information about the graph of the derivative of f, specifically where f prime has horizontal tangent lines, and the areas of certain regions bounded between the graph of f prime and the x-axis. In part A of the question, we are asked to find all x where f of x has a relative maximum and to provide an explanation. So we're given in the question stem that f is twice differentiable. This means that the graph of f prime, which is provided, is a continuous function. That's good to know. The graph of f will have a relative maximum anywhere where f prime is equal to 0 and changes from positive to negative. Now, because we only know a little bit about f and most of everything we know is about f prime, our justifications and our explanations should refer to the given information, which in this case is the graph of f prime. So our justifications for this need to be based on what we can see and infer about the graph of f prime. So based on the graph of the derivative of f that's given, the derivative of f is equal to 0 and changes from positive to negative only at x equals negative 2. F prime is 0 in a couple of other places, but it doesn't change from positive to negative at any of those places except at x equals negative 2. So the only relative maximum for f is at x equals negative 2. In part B of the question, we are to consider the open interval from negative 3 to 4 and determine when on that interval the graph is concave down and decreasing. On the open interval from negative 3 to 4, the graph will be concave down and decreasing whenever the derivative of f is less than 0 and is itself decreasing. So we need the derivative of f to be negative, which would indicate where the graph of f is decreasing, and we need the derivative of f to be decreasing itself, which would mean the second derivative is negative, which would mean that f is concave down. Well, we're given in the question stem that the derivative of f has horizontal tangent lines at x equals negative 1, x equals positive 1, and x equals positive 3. So based on the information given in the question stem and the graph of the derivative of f provided, the derivative of f is negative and decreasing on the interval from negative 2 to 1 and also from 1 to 3. In part C, we are asked to find the x-coordinate for all inflection points of f and to justify. The graph of f is going to have an inflection point wherever the second derivative of f is equal to 0 and changes sign. But again, we only really know a lot about the derivative of f. We have its graph. We don't know much about f at all. We have a lot of information about the graph of f prime. So our justification really ought to focus on things we can get from the graph of f prime. The only thing we know about f double prime is what we can infer from the given information and the graph of the derivative of f that we are provided. Therefore, f of x will have an inflection point wherever the derivative of f changes between increasing and decreasing. Based on the given information and the graph of the derivative of f, f prime changes from increasing to decreasing at x equals 1, and from decreasing to increasing at x equals negative 1 and x equals 3. Therefore, the graph of f will have inflection points at x equals negative 1, positive 1, and 3. In part D of this question, we are given that f of 1 is equal to 3. We are asked to write an integral expression for finding the value of any f of x, and then we are to use that function to find f of 4 and f of negative 2. Since we're given that f of 1 is equal to 3, we can use the fundamental theorem here to come up with a rule for f of x. f of x would just be 3 plus the integral from 1 to x of f prime of x dx. All right, that will get us f of any x that we want. We just have to be able to calculate that integral. All right, we're given in the question stem that the area of the region bounded between the graph of f prime and the x-axis between -2 and 1 is 9, and the graph of the region between the graph of f prime between 1 and 4 is 12. Now that just tells us about the area of that region. It doesn't give us the value of that integral. All right, the value of that integral will depend on whether or not the graph of f prime is above the x-axis or below the x-axis. All right, based on the graph provided, the derivative of f is negative for all x between -2 and 1. It's also negative for all x between 1 and 4. So we may conclude based on this that those integrals, the integral from -2 to 1 of f prime of x dx, is actually -9, and the integral from 1 to 4 of f prime of x dx is actually -12. Right? There's a difference between the area of a region, which is never negative, and area as an expression for a value of an integral. When we integrate a rate function, the area, in quotes, can be negative because we're talking about net change. When we're just talking about the area of a region, that's never negative. All right, so given that f of 1 is equal to 3 and that f of x can be found by doing 3 plus the integral from 1 to x of f prime of x dx, the integral from -2 to 1 of f prime of x dx equals -9, and the integral from 1 to 4 of f prime of x dx equals -12, we can conclude that f of -2 is 3 minus the integral from 1 to -2 of f prime of x dx, which is 3 minus -9, which is 12. So f of -2 is 12. Likewise, f of 4 is 3 plus the integral from 1 to 4 of f prime of x dx, which is 3 plus -12, and that turns out to be -9. So f of 4 is -9.